Hello, welcome back to our organic chemistry lecture series. As you notice, we've changed locations again. We're now in an undisclosed location, also known as my house. One of the good things about lecturing in my house is that I don't have to wear shoes. So hopefully we'll see improved lectures without shoes, and we'll see how that goes. And today we got some exciting chemistry we're going to talk about. We're talking about enolate chemistry and enol chemistry, right? And some of the new reactions we can do. It's really this idea of we can start really making these carbon-carbon bonds, right? That's all about organic chemistry, is making carbon-carbon bonds. So let's look at that. We're going to be working with carbonyls again, right, that we've done before. So if we draw out our carbonyl here, we're going to work on this carbon here. This carbon here is known as our alpha carbon. This is where everything's going to happen at, is that alpha carbon there. This is where we're going to make some new bonds. This is where new things are going to attach at that alpha carbon. And as we talked about here, we're going to go in two directions in the lecture series. We have our enol, okay? And our enol, it's going to look like this, where we have a double bond directly attached to that OH group there. That's going to be our enol, okay? That's going to be our enol. For our other one, our enolate, it's going to be our carbonyl with this lone pair of electrons at that alpha carbon. Remember we talked about that being the alpha carbon? Okay? And we can see this one had a carbon being very nucleophilic, has a lone pair of electrons. In fact, both of these groups here are going to be nucleophiles. They're both going to be nucleophiles. So that's going to come in handy later on when we start talking about this idea that these are going to be our nucleophiles, and they're going to attack what? They're going to attack electrophiles. So we'll prepare our nucleophiles first, and then we'll go about and see how we can then do some chemistry with them, right? Add them into react them with some electrophiles, okay? And so in this lecture today, let's talk about how we can make an enol and how we can make an enolate. The enol, we have two ways to make an enol, an acid catalyzed version and a base catalyzed version to make our enol. Enolate, it's pretty much just one way using a strong base to generate our enolate, okay? And we'll talk about that. So let's start with our enol and then work our way to our enolate. All right. So as we said for our enol, we're going to have two methods to make our enol. So let's look at the acid catalyzed. And so with our acid catalyzed version, we're going to do what? We're going to add in our acid, and guess what? We're using an old friend, our hydronium ion, right? H3O plus. And what we're going to do with this is we're going to use this to protonate something, right? And now, as we saw before, this is going to protonate something. What have we protonated before? What do you think we're going to protonate on our molecule? In this case, you only have one thing to protonate, right? Okay, we've seen this before, nothing too new. All right, we get that positive charge on that oxygen, as we saw before, right? Electrons are going to move up. This form here, and remember this is acid catalyzed. This OH group once gets its proton back, and so what we're going to have now is this one's here is going to come and take a proton. It's going to take a proton from here to regenerate our H3O plus. Plus we get this what? This is our enol, right? We made our enol. Notice I have this double bond directly attached to this OH group. This is going to be our enol, okay? We'll use this to do some chemistry with. This is the acid catalyzed version, using acid, okay, to make our enol. Now, we can do the same thing and make an enol using base catalyzed conditions, right? And so with the base catalyzed conditions will be slightly different, right? Slightly different. So let's look at that for our enol. All right, so let's look at this now with our enol. This is going to be with the base. In this case here, let's use OH. Okay, and you can guess what's going to happen already. We want to make a double bond here, and we want an OH group here, right? So our OH is going to do what? It's going to actually take a proton here, As it takes a proton there, what's going to happen? These electrons are going to go here, and these electrons are going to go here. Okay, we're almost where we need to be, right? We're almost to our enol. What are we missing in our enol? We're missing what? The OH group there. But remember, this OH group just took a proton over water. Oh, let's rewrite that, make it look a little nicer. And so what? This is going to take a proton. And so by doing that, we make our enol, plus we're going to regenerate our base in this, right? It's base catalyzed. Every time we see it base catalyzed, we should get our base back. Anytime it's acid catalyzed, we should get our acid back. And so we finish this up. We generate our enol, right? A little different we saw for our acid catalyzed version. In this case here, our OH group is going to take off that proton. We're going to generate the double bond, right? And then the second step then is our oxygen is going to take the proton to generate our enol, okay? To generate our enol, right? So we can make our enol using acid conditions or under basic conditions as well, right? What do we have left? Well, we still got to talk about the enolate, right? Enolate one. Now, enolate one, as we talked about before, there's no acid mechanism. It's all going to be a base using a strong base, right? We're going to use a strong base, and right now we'll call the base B. And then later on, we'll talk about what bases can we use to remove this proton. Already I talked a little about this idea. This proton here, pK of this is going to be around 20, right? Again, it's a little bit lower than normally we see. Normally we see pK for a CH bond is going to be around 50, right? But this case here, it's around 20. Why do you think it's so much lower? Well, we'll see that in a second when this base takes off the proton. We get to this form here, right? Where we have a negative charge in the oxygen, and we get this double bond in, right? Almost looks like an enol, right? But look what's happening here. I can draw electrons coming down here, and electrons coming here. What did I draw? Remember I drew our old friend, our best friend. Draw a resonance structure of that. And so what's happening? The negative charge can be delocalized over this carbon and then oxygen there, right? Over both places. That's why we see the pK value is a little bit lower, because that negative charge is slightly stabilized, right? Stabilized by being sometimes a carbon, sometimes the oxygen here, right? It's delocalized over multiple atoms. And this right here is going to be our enolate. Okay, that's going to be our enolate, right? That's our enolate. And so we can see here, we have a carbonyl directly attached to this carbon that has a lone pair of electrons on here, okay? This has got that negative charge on it, right? We have two resonance structures to work with here, but this is going to be our form that we use to work as our nucleophile, this carbon here. We have a nucleophile carbon. What we'll have to talk about later on is about the base. What's appropriate base that we use to deprotonate this, right? It gives us a clue when the pK value is around 20, we got to figure out what type of base to be able to deprotonate that, right? And that's something we'll talk a little bit more about as we move forward and start looking at some of the reactivity of that, some reactions we can do, okay? So we know how to make an enol from acid catalyzed and a base catalyzed, and we know how to make our enolate using a strong base. And we'll talk a little more about what that strong base can be.